Hello from Romania, from your favorite artist electronics, Mr. Q12 here. This guy here. I believe I can call it finished, absolutely finished, this project with lock, electronic lock. Because I managed to make some sort of a case. I know it's not what I imagined in the beginning, in the very end, but it's good enough. It's good enough for what it is. I mean, it's having a minimum. This is what I call a minimum of protection, because it is a project about flip-flops, and I wanted to make it, to have it in reality as a device, as a standalone device. And I made this very cheap, very nasty. Let me first let you see how it works. These markings here are the button location. When I'm pressing through the cardboard, is actually triggering the button. After I made this cardboard, I realized that some buttons, I'm not sure how good you can see. Yeah, you can see it. You see some buttons are a bit higher, that one there, and some are a bit lower. And you have to bend it quite hard, and this is not so much. But here you have to press it quite, low to actually make this connection. And the majority are low, and only two I have them a little bit high. And the majority are low, like this one here. And here is the code that you input, and voila, that LED. That is not pink. I have too much light here. That is quite red in reality, but here in the video it's looking like it's pink, which is hilarious, but it's good. And I actually thought 2 or 3 days how to make the case, and I tried a lot of stuff. So this is the normal placement. Yeah. So if you are pressing one of these buttons, the markings, those square markings, so this is the code. I know it's a stupid code. It's probably easy to catch, to guess or to hack, but it's not really the subject of this project. The subject of this project, it was, like I said 1,000 times already, is to have an exercise about flip-flops. And it's very, very cool project. I really like it how it's come out. Even as flimsy and as shitty as it is, at least the case is having this minimum protection that I have here. Is I also used the other cardboard from the Colgate. Here on the back I put another stiffer and harder cardboard, and right now is not bending by itself in any way. It is very impossible. You have to use quite some force to bend it. And if it's used in normal use, if it's used vertically, screwed on a wall or on a door of some kind, the pressure will not bend anything. It will press directly on its back, and it's absolutely fine. So doesn't matter how you press here, nothing will bend all around. So it's a good project, ready to be used actually. This thing can be used as a electronic lock. And let me like that. This and this, and yeah, it's quite nice. I like it. The LED arrangement is it's stupid a little bit. I don't like it, but it's good enough. I mean, yeah. If it's vertical, but it's very, very functional, and I really like it, and it's working absolutely fine as I thought it in 3D, and then I laid out here. Let me show you how this. It's very, very simplistic protection what I have here. I literally have a paper here that I bend it. Let me see if I can. No, I cannot do it with one hand. So let me do it with 2 hands. Focus. So this is how I'm taking out this thing. I'm taking out this thing, which is quite hard to put back. I couldn't. I had a ton of variation. No, not really a ton of variation. And that's it. This is it. I get to the circuit part, and very easy, extremely easy to to take it out, and quite easy to put it in. Not that easy actually, but it is very close to what I envisioned it to be. And forget my boo-boo. I have there a boo-boo. This is just a spacer, just when I'm pressing it, not to bend, to stay at a certain height. There's nothing spectacular, nothing important really. I did made a lot of mistakes, and I correct them. Initially, I didn't film it. I didn't make a picture of it, unfortunately. Initially, I made the holes. You see, these holes are not. You see, it's not exactly 3 millimeter as the diameter of the LED is. They are a bit more larger. If I'm not mistaken, like 5 millimeters or 4, and probably 4. And I had to enlarge them because nothing fit. Every LED was, and I had to bend them quite drastically to actually fit on its hole. And I took the measurements as best as I could, and I couldn't really catch them exactly on their position. I have to actually calculate and make a grid, like a grid or something, or like a mold, where I'm putting perfectly on the position every LED perfectly straight and perfectly left, right, and up, down. And like something that is like a matrix. I don't know how to say it. Like a negative. When you like a helper, a help device. When you centrate the LED and you put it perfectly on a same position for everything, on the same spot, in the same line, and vertically and horizontally. And I don't. This is homemade after all. And there are a lot of deviation, very small deviation, but they are quite important when you have that small, very small very fitting hole in the cardboard, and it's not working. It's just chaos. And also these ones, as probably you can see, they are not perfectly centered, perfectly aligned. One is a little bit there, one is a little bit here. There is not perfectly one after another. It's not the same distance between them, and they are bent around like the wind is blowing. And let me put this back again. And that's the problem. That was the problem. I stayed 2 days and think about how the hell can I make the case to be good enough. Not something fancy as I originally thought, with like a metal case I was thinking, or even a wood case. I was thinking a bit more fancier than this. And I can make it, no problem, but is it worth it? For a small, I don't know, teachable project like this one, this is like a tutorial almost, you know, how to make a locking circuit using logic ICs. And this is a bit hard to put it here because it's quite, I have to use my tweezer. Yeah, that's it. I only have to catch it once there, and that's it. And it's quite good. It's a piece of paper. I put a little bit of scotch here, and that's it. And the same here. And voila, I have a minimum. I was thinking to add here as well, like, but it was harder to take it out. But it was grabbing, you know, in position from the middle. Right now in the middle is staying like a little bit bolted, like that. You see? Yeah, but it's good enough. I know. I believe. So this is click. You can press them both. It's no problem. Let me reset. So this. And it's not that hard to probably to figure it out by a hacker, which is the bad news. But this was not about hackability. If you want to make it very hard to guess, you can put. So I have these 6 reset buttons that are all linked together. I have here probably. No, not that one. This one. This is the good circuit. All this. You see this line, reset line here. This reset line. Everything is linked together to it, and this reset pins from the chip to this line, and also all these emitters from the PNPs transistors. So pretty much you can add however many buttons you want. You can add 50 fucking buttons you can add. And good luck to to discover the the correct code. And also, if you separate this, not put them close together as I put them here, because convenience. I like to be convenient. But if you are putting it here, there, and there, and it's quite hard to figure it out. Also, if I'm pressing here and if I'm pressing a reset, that gate is resetted. So I have to press it again, and then this one here. And if I'm pressing again one of the reset buttons somewhere, both of them got reset. So if you don't know the code, you are pressing correctly here, but pressing here, it will reset it. And only the correct arrangement, like that and like that, it will open the lock. So pretty much, yeah, I want to show you the my failures. Not that many. One failure was this very small, very fitting hole that I enlarged. Also here, as you can see, I made a larger hole. Initially, I made the round holes for each transistor very fitting, very perfectly, and it wasn't perfect by a long shot. No, not really. And then I decided to cut the cardboard around. And even if I cut the cardboard around, they are still more on this side. And you know, shit. And then I got after 2 days, after a good sleep, and I wake up and I was scratching my brains. How the fuck can I do this? And I decided, well, a little bit larger hole will not be the end of the universe. And also that fitting hole that I was having was ondulating the cardboard. This way is staying quite, you know, semi-straight, quite straight is staying right now. And having a little bit of tolerance there and there, it's absolutely cool. It's okay, even if it's staying bolted like that. I was thinking on all of these effects actually before starting, and I said in my mind, well, I will see how bolted it will be, and it's okay, it's acceptable. And if I really want it, I can add some string. Sewing string, wrap it around, or another piece of paper like this, put it somewhere all this way here. Probably it's an idea to actually keep it up very flat and appealing, you know. But it's really no need. It's good enough as it is. And other mistakes that I made, I didn't know how to make all this, and I really wanted a single board, cardboard, on the front here. But in the beginnings, I don't find the other one. I had 5 of these. The other one got loose. Probably I think I used it there as a dispenser. Yeah, probably. So I had 5 of this, and as you can see, the hole is fitting exactly the LEDs. I was thinking to glue them somehow together, and I didn't really like it. I was having very big disproportions, very unfitting holes, unfitting position of the cardboard. It was too much like that. Even if I measure it, and it was still wrong. I don't know why, but it is. It was. Some of them were perfectly as I designed them, but some of them they just got weird, stupid on me, and I got very depressed for 1 or 2 days, and then I got back to my senses. I get very easily depressed because I'm an artist, and that's the life of an artist, living with depression. Also because I don't have a chance to get any kind of money, especially at my age, and that's cruel. But anyway, so yeah, this was another mistake. This is how I started everything actually, and I used almost the entire cardboard from the Colgate case. It is very flimsy and bendable, but this one is not. Is quite stiff. Also, because of this very stronger and very thinner cardboard that I've added, especially for this purpose, for reinforcement. As you can guess, it's from a multimeter. These are the probes from that multimeter. And I put aside a lot of cardboards of different strength, and now I'm collecting the the benefits from them, from some of them. I don't have many very good cardboards. They are kind of the majority of cardboards that I have are in the middle line. Not that good, not very good, not very bad. But some are very bad, especially for longer circuits. You see how shit it is. Like this was the original circuit, like this, bendable. when I built this the first time, and I didn't waste too much cardboard. I actually used everything that I had, and I'm quite proud that I didn't throw away too much material, because it's one thing about me. I like to build stuff that that I can repurpose. I like to repurpose the normal stuff, and give it a new sense, a new direction, a new functionality, pretty much. And it's a hobby and a pleasure. It's a pleasure of mine. And yeah, this is the button. I draw it. It's a very smart idea, actually. I really like it. Another thing about this, if I have to leave it on the cardboard will get dirty, especially in the locations where you press the most, and especially on the code area. So it is a giveaway. It's already probably a bit more dirtier here, but it's not that visible yet. But it will be in the future. So my idea is to add plastic, transparent plastic, at least on the buttons where you press. Like this thick, this wide, or even encompassing the LEDs. I don't know, transparent one. Like a plexiglass probably. It's an idea. Or to add to actually put it under plastic, to plastify this cardboard, to take it out from here, to put it in a machine that is plastifying in vid, in void. It's voiding the air, and then it's plastifying it, and that's an idea. But I'm not sure if I will ever do it. Like I said, this is a home project. It's quite elegant, and it's functional. It's very functional. It's extremely functional. As stupid the code as it is here, you can change it pretty easy. Well, not after. You have to change it in the designing stage, not right now. Right now it's fixed, and this is the very bad thing about this device. Another detail is that I use this punching. This is used for making holes in leather, actually, and it's very sharp here, very, very sharp. And I mounted it here in the drill chuck. Here you can see the holes it left. And I use two sizes for that size, and that's one size, and that's another size in the cardboard. And yeah, it worked absolutely. You can see how clean, well, acceptable clean it is, the hole. Pretty good. Actually, I will have to add here its name, electronic lock. So, electronic lock. Actually, I should have written it in vertically like this, because this is how it's supposed to, but I got used to use it on horizontal. Anyway, so this is its name by Mr. Q12. And that's Mr. Q12. You see how beautiful it is? All right, this is it. Thank you very much. I hope you like it. My finished project, and I like it. I really like it. It was hard, a bit more harder than I expected. Really, it did surprise me, because it was a bit more harder. And but in the end, I managed to finish it. Yay! Thank you very much, and see you later. Bye bye. From your favorite artist electronist, Mr. Q12. All right. Bye bye.